Start the recording. Hi, everybody. Thanks for joining today. Our last WISM talk of the semester. Today, we're pleased to have Alex Cernat. Am I saying that correctly?
Yeah.
Okay. From the University of Manchester. Going to be talking a little bit about digital trace data. So yeah, we're excited to have you. 30 minutes for presentation. Alex might be a little bit less than that, but you can put your questions in the chat or wait until the Q&A to ask your question live. But I'll turn it over to Alex now.
Excellent. Thank you so much for having me. I really appreciated the invitation. And this is joint work with Florian and Ruben from University of Mannheim and Paulina from Utrecht University. And it's kind of ongoing work. We started thinking about this experiment, this data collection I'm going to present a few years ago. We finally collected the data last year, and now we're in the middle of analyzing it and trying to understand what we found. So keep that in mind when you look at the results. It's kind of work in progress, but I think it's interesting enough to start a debate around this. So just kind of to give you a general overview. So we know that in the social science, like as a society, we're moving more and more of our behaviors online. And as researchers, we need to collect more information about that. So this could be, how we communicate with our family and friends, how we learn about what's happening in the world through news, how we interact with the government, and so on. So a lot of our behavior are moving online, and collecting data about this is really key in a number of different fields. So from political science, where we want to know, okay, where do people get their information from? How does information spread? To other areas like communication sciences or social network analysis, understanding networks of individuals, and so on. So I'm collecting data about online behavior and trying to be as precise as possible is really, really important. And traditionally, as social scientists, the way we collected this kind of information was with surveys. So as most of you are involved probably in LAPOP, which is a very large, very important study. You know how essential are surveys, or especially traditional surveys, in understanding the social world. And this is how we used to go about it. We used to ask people, okay, how about their behaviors, and now if their behaviors are moving online, we tended to use the same methods. We would just ask them, okay, how often, I don't know, do you talk to your friends online? How often you read the news online, and so on. So we kind of adapted the old methods of collecting data to the new kind of reality of online behavior. So I want to kind of present 3 different strategies in which we can collect information about online behavior. So I said the traditional way is to use surveys, and this has advantages and some disadvantages. So one of the big advantages is that we have this very strong theory from probability samples, so we can use random selection and try to have a good representation of the population. And this is, I think, still a very important advantage for surveys versus other types of data, because we can draw inferences, even if response rates maybe are lower than they used to. We can still use probability theory to make good inferences about the general population. Another advantage of surveys is the freedom of design. So we can design, how often to interview people, how to measure the concepts of interest, how long the survey is, the mode of interview, incentives, and so on. So if we collect our own data, we have freedom for the design. So we can make a really good design. And this is different from using some data that already exists, from administrative data to social media data, and so on. And another, I think, really big advantage that maybe it's not appreciated enough is long-term comparability. So, some of these platforms or these different ways to collect data, they are present now, but we don't know if they're going to be here in 5 years. And if we want to make comparison in the long in the long period, we really need to be careful of, keeping the infrastructure that makes it possible for us to compare data with previous years, and also to be able to make comparisons in the future. I think these are really important advantages for surveys, and I don't think surveys will go away. Keeping that in mind, there are some limitations of survey that we need to appreciate. First is the information we get is discrete. So even if you have a longitudinal data or repeated cross-sectional data like LAPOP, we ask people about a particular discrete period, and also the kind of information we ask tends to be discrete. So if I asked you, okay, how many times did you check your email in the last week? You're not going to be very precise. You can't really say, 152 times I checked my email in the last week. You're going to approximate and say either how you feel, is it a lot or not a lot, or just kind of approximate somehow. The other thing is surveys can be burdensome. So, surveys like health and retirement study, they can take 4 hours, and, can involve lots of different activities, from taking your blood to other types of activities. Even if a shorter survey, like a half an hour, it's relatively high burden for some respondents. And then we know there's a huge literature that this data also has measurement error. So, people might forget things, their social desirability, so they might decide not to be honest about the answers. There might be low reliability, so people are not consistent in their answers, and so on. So there's lots of different types of measurement error that exist in surveys. We have a big literature trying to estimate and correct for them, trying to minimize them by design, but they're still there. So that's one strategy. Another strategy that I'm going to talk about today is digital meter data. And for those of you that don't know about this type of data, the way it normally works is, let's say on your phone or your computer, you install an app that kind of tracks what you're doing on the device. So for example, on your phone, you install the app, and the app will capture typically a couple of things. It can capture more information, but it would know, for example, what app you're using and for how long. So let's say if you're opening WhatsApp, sending some messages, closing it, it would give you a timestamp saying, okay, WhatsApp was used at this particular time for 5 minutes. You won't know what's happening inside the app, but you know that the person used that app for that period in that time. Then it would know, for example, the websites that you visit with the main browser. So if you, let's say, use Android and use Chrome and go and, read The Guardian, then it will know you went on The Guardian, and it will know the link as well. Yeah. And depending on the meter, it might not know the full link or just the main address. So it will know The Guardian, but not the article you read. For others, it would actually know the full link. Some newer ones, they could actually download the HTML. So actually have the full information about the web page you're visiting. And then another thing would be things like Google searches. So it will know if you're searching for something on your phone on Google, it will know what you're doing. And you can install something similar on your computer. So normally that would be like an add-in in your browser, and that will track on that particular browser all the pages that you've been to. Again, with the timestamp, the website, and again, sometimes it will have the full link, sometimes it's just the root of the website. So that's digital meter data. Yeah, so people install it, and then this data is collected continuously. And there are different ways. I mean, it can be sent every day or live, or there are different systems in which that data can be collected. So this data is very attractive because it's a direct measurement of what people are actually doing. Yeah, so we know in each, how many seconds they spent doing different types of activity on their phone and on their PC if they have something there. It's relatively low burden. So once you install these apps, they just track things continuously. The respondent doesn't really need to do anything. If you collect other data like GPS, it might be annoying because it tends to drain the battery a lot. But if you have these minimal things, in principle, there's no issue. The respondent doesn't really observe anymore that the data is collected. And like I said, it's very high frequency, very detailed. So you know at the second level what people are doing on their device. Some of the weaknesses, it's kind of hard to install these trackers on a large population. So, I'm not sure if there's an example of a survey like LAPOP that installed something like this, right? So normally these are installed in small populations. They tend to be quite selective, I know, from students or case studies where they have these. And there's fewer examples where you have a representative or a probability sample where that install this kind of devices. It depends on technology. So if the technology changes, if Android does an update, things might not work anymore. So you need to, make sure that this works, and there's no guarantee that in the future it will work or the data will look the same. And even if we think, oh, this data is perfect, we can just measure this, and there are different types of measurement error that appear. So first of all, people can turn off the tracker, and the problem is that normally you don't know when they turn off the tracker. So you might say, oh, they're not doing anything, but actually the tracker is closed. So that's one type of measurement error. Or you can think of it as missing data if you want. We don't have information, and that might be just because the tracker is closed. And then there are other issues. So multiple people can use the same device. Let's say you have a tablet, then maybe multiple people in the household use the tablet. If it's a PC, the chances are even larger. And also people have multiple devices. So they could use a different device, one for work, one for, I don't know, watching TV, and one for chatting with friends. And maybe you don't have the tracker on all the devices. So these data, they have some advantages, but they're really not perfect. And then another way to collect data, and this is relatively new, is data donation. So this is kind of building partially on GDPR. So if you don't know, GDPR is this legislation developed in the EU regarding data privacy. And one of the things that GDPR requires platforms, big companies that collect data, is that the user should be able to download their own data in a format that is easy to understand and use. So if I go to Facebook or if I go to Google, there should be a way in which I can download all my data so I know what Facebook and Google know about me. So you can do that, and as an experiment, you can go and try to download your own data from some of these platforms, and I don't know, you might be surprised to see what you find. So for example, you can see what Facebook thinks about you. So you can see what are your interests based on what Facebook, the data that Facebook has on you. So recently, a few teams, so I think 2 from the Netherlands or 1 from the Netherlands, 1 from the Spain, they're developing some platforms. So the idea would be people download their own data, and then you go to this platform and you donate your data to a researcher. So we ask you, okay, can you download your Facebook data? There are lots of types of data, so we can tell you, okay, we want to know when you logged in or your network of friends or something like that. And then you go and put it on this platform, and then you basically give consent that the researcher can use that data. And this is quite exciting. First of all, these platforms are being developed so they maintain privacy. So the user decides what data to be shared with what researcher, and also they're developing ways in which maybe the data is not shared, but just some summary statistics or some ways in which privacy is maintained. In principle, it should work with any platforms. As long as they're in the EU, they are obliged to do this. And normally the data is in a format like JSON or HTML. And users have this control about what data to share. There are some disadvantages. So it's quite a complicated process. So when we did this, I don't remember, I think it was like 20 steps that they had to follow in order to download the data and then rename it and then put it on the platform and so on. And I think this is being improved. So, as with the passing of time, we can probably do this more efficient, but it will work, it won't be an API or something. There will be still a process involved in which people need to download, might need to wait a day or 2 until they actually get the data and then upload it. So it is kind of a convoluted process. Sometimes it's hard to link the data. So if you have a survey with that individual and then you invite them to do the data donation, sometimes it's hard to link those two things. Again, this could be improved in the future, but at least with the platform we used, that has some limitations. And like I said, it's not user friendly. One thing I'd mentioned, so I didn't put it in at the strengths, but if I would want to look at something like Facebook use, a big strength of this is that Facebook actually knows all the times you logged in. So it doesn't depend on any platforms or anything like like that. So it is a very big strength that in some ways it should have less measurement error, but might have more selection error because it's hard to convince people to go through this convoluted process to give you the data. Okay, so these are the three types of data that different ways to collect data about online behavior that I want to discuss about today. And the general kind of overall question that we had was, well, what's the best way to measure online behavior? And a lot of, especially if you look kind of political science, communication science, you'll see that the digital trace data is kind of considered as a gold standard. So there are people that just say, okay, this is the truth. Yeah, we don't believe surveys because all of these types of measurement error, if we use digital trace data, this is perfect. There's no issue. And now we have this very precise data and we can do whatever we want with it. But our argument overall is that, well, that really ignores the other issue that this data have. And it's really, I think, too soon to say that this is the gold standard and we should, give up surveys and stop asking people about their online behavior. And we should really think, okay, what are the different types of measurement error that exist in different types of data? So why is this important? So why should we care? So with our colleagues, what we did is we used the data that I'm going to present in a second, and we looked at a couple of different outcomes. So trust in politics, media, democracy, attitudes towards the environment, climate, and so on. So different outcomes. We had a regression model with some controls, and then we did the same analysis where we looked at how much people used Facebook and how that impacts all of these outcomes. And we did it separately if we use digital trace data, which I call tracking here, and surveys. And you see sometimes they agree. So for example, for politics, it seems that they're both around 0. But for other things, they don't agree. So if you look at position left to right, for the survey, it appears that there's an effect that is statistically significant. For the digital trace data, it appears that it's not statistically significant. So if I use one data source, I have one conclusion. If I use another source, I have a different conclusion. And depending on the outcome, so attitudes toward climate, again, very big difference there. So depending on the outcome, I could have different conclusions. So, and then what's the correct answer? We could say, like some of our colleagues say, we could say, well, digital trace data for sure is correct, so we should trust that. But like I said, well, that's not perfect. We know that's not perfect either. So I'm not sure if it might be a little too soon to assume that. So what I'm going to do is I'm going to show you a design which we developed. I think it's relatively innovative. And then I'm going to show you 2 little papers or results that we are working on. So this is our design. So we started with a survey and it kind of has a typical kind of election political science design. So we had 3 waves of data with the same individuals. So the first one, 29th of 8th, 21, the last one in the 4th of the 10th. And I think 2 waves were before the German election and 1 was after. And our sample is from Germany. We have around 2,000 people. And this is based on a non-probability survey in Germany that used some quotas on some key social demographics. So it's not a probability survey. Like I said, it's very hard to get digital trace data from a probability survey, but it's a relatively large sample with quotas on key social demographics. So this was the survey. So it's like a panel study with 3 waves. And then for all of these individuals, like I said, around 2,000 individuals, we had digital trace data from their phone. And this included 2 main types of data. One was app usage. So we knew the apps they were using at what time. So like I said, we had timestamps for every time they used a particular app. And then the website they visited and their Google searches. So this was the information. And this covered the same period like the surveys. It started a few weeks in advance and then it covered the same period. And you see here, it's kind of continuous. So we have the data for the entire period while the survey is kind of discrete. We had 3 waves at 3 different points in time. Also, most people, not everyone, installed a plugin on their main browser on their PC that also followed the websites they visited using that browser. So we also had PC information for some of the individuals. Then at the end, we had the last survey, which was a very short survey, and then we invited people to donate their data regarding Facebook. So the survey covers a wide range of topics, but this last data donation is data from Facebook. We invited people to answer a few questions. Then we asked them, could you donate the data? And we had this step-by-step guide how to donate their Facebook data. And the main thing we were interested in is actually kind of a log of how many times they went to Facebook, and also their interests based on what Facebook thought about them. And the way the donation works is we ask them to collect the data over this entire period that covers the survey. So when they upload it, it should cover the same period that we had for the survey and for the digital trace data. And finally, we had like a small follow-up study somewhere between wave 1 and 2 of the survey. And this was like a re-interview experiment. So for those of you that have experience with surveys and kind of reliability, one way to look at reliability is by asking the people the same question again, and then see how consistent they are. So we had this idea of somewhere between wave 1 and 2, around a week after the first interview, we re-interview people and ask them some questions that were in the first survey in a slightly different way in order to estimate data quality. Okay, so we have this complicated design where we have 3 sources of data, so survey, digital trace data, data donation from Facebook, and we have this kind of quasi-experimental design where in wave 2 we had an experiment where we re-interview people in a slightly different way to be able to estimate data quality. So I'm going to present kind of 2 different ways in which we look at the data. There are a few other papers we're working on, but this should give you a flavor what we're looking at and the kind of findings we're seeing. So first, we wanted to compare survey data and digital trace data, and we wanted to go beyond a simple comparison. And instead of just assuming, either of them are perfect, we wanted to be able to estimate data quality for both of them and say, okay, they're both imperfect, but in what way? And the design we use is similar to a multi-trait, multi-method approach. So for those of you who know, the idea is it's basically like a re-interview design where we ask people some questions, then we ask them the same questions in a slightly different way a week later, let's say, and then we compare, and that we are able, using some statistical modeling, to get reliability and validity, okay? And we do this both for the survey and for the digital trace data. And I'm going to explain in a second the topics that we looked at. So like I said, the general question was about how best to measure online behavior. And we looked at, in this case, at 5 topics. So we wanted to know how people use their phone to make calls, to write text messages, to take photos, for social media and web browsing. So we said, okay, these are the topics that we're interested in. And what we're comparing, well, the data that we're using for the study is basically, we have 2 measures from the survey. We have the first wave and the re-interview. We call it wave 1B. And then we have the digital trace data from the phone. So these are the things that we are basically comparing here. For the survey, we had 3 different ways to ask about these topics. So we could use a 5-point scale, a 7-point scale, or 2 questions about duration. So how long it takes in hours and minutes, how long they think they do that activity. And we looked at basically how other studies out there, from the Eurobarometer to ESS, European Value Study, and so on. And we looked at, okay, how do surveys normally collect this data? And we try to use the typical scales that exist out there. These scales are not great. So when we're doing this, we're thinking, well, probably this could be improved. And I think partially a few of them exist just because of this is the way things have been done for a long time. So you see the 5-point scale goes from once a month to several times a day. The 7-point scale from less than once a month to several times a day. And the duration, there were 2 questions, how many hours and how many minutes. And the way the experimental design works, we had 3 random groups. Each group received the questions on the 5 topics using one of these response scales. And then in the re-interview, they get the same topics, but with a different method. So let's say in the first time they got 5-point scale, then they get 7-point scale. So we have this within experimental design, 2 measures from the same individuals using 2 different methods. From the digital trace data, we looked at how much they did those 5 activities on their phone. And we coded in 2 different ways. One is how many times they did the activity, and the other one is how much time they spent doing the activity. So we kind of have 2 different ways also from the digital trace data to measure those topics. For the modeling, I'm not going to go into detail, but I'm happy to discuss in the Q&A. We did basically a latent variable model. What you see here, the squares are the observed measurements. So for example, this is calling using the 5-point scale from the survey, the 7-point scale from the survey, duration from the survey, and then the count and duration from the digital trace data. So these are the measures for calling. We say, okay, this should measure a latent variable T1, which is calling. And then on the bottom, these are the method effects or the kind of lack of validity or the amount of variation that is due to that particular method of data collection. So this is a way in which you can separate valid variation from variation that is specific to the way you ask the question. And also you can get estimates of reliability. Okay. So like I said, I'm happy to talk more about this, but it's basically an adaptation of the traditional multitrait multi-method approach to this design with multiple data sources. So let's look at some exploratory analysis before I show you the results. So here, this is a correlation matrix, and the way to read it is, for example, this is the measure for calling using a 5-point scale from the survey, using a 7-point scale from the survey, using the duration from the survey. So these 3 measure the same topic, so they should be highly correlated. So you see, this is the case. It does seem that the 5 and 7-point scale are a little more correlated than they are the duration. So, and this also makes sense. 5 and 7-point scale are a little more similar to each other. We see they're not perfect. So if we look at taking photos, 5 and 7, very high correlation. The duration has relatively low correlation with these other 2 measures. Okay, so this is one part of the puzzle. This is the data from the survey. If we look at the data from the digital trace data, we see that there's a very high correlation between the count and duration. So they're very, very similar. But if we put all of them together, so this, for example, the square on the top left are the 5 different measures for calling. We see that actually the survey and the digital trace data have almost 0 correlation. So the very, very weak correlation. So it would appear that the survey and the digital trace data are measuring different things. And this is pretty consistent for different topics, which is slightly concerning, yeah, because in principle, they should be measuring the same thing. So what does this imply for the results? So with this method that we use, you can actually do something called like a decomposition of variation. So we can see the amount of variation we have for each question, and we can decompose that in trait, which is actually the thing we want to measure. So we would think of this as, good data quality. Then the method variance, which depends on the way you ask the question, and ideally we would want that to be as small as possible. And then random error, which is just noise. And we see the data quality, at least based on this method, seems to be pretty poor. The digital trace data does seems to be a little to be better than the survey data, but as I'm going to show you, it's not always the case. So if we look here separately for each topic, we see that for some topics like social media and web browsing, digital trace data does seem to be a little better. But for other topics like messaging, for some reason, this doesn't seem to be very consistent. And we're still trying to figure out why this is the case. Might be the way we define messaging. Maybe it's different the way we code it versus the way people think about it. But it seems for some reason, data quality seems to be lower here. And it's the same for calling, seems to be slightly lower. So based on this first study, it seems that digital trace data can be more precise, but it's far from perfect. So the trait isn't 100%. So there's still random error and method effects there. For some topics, there seem to be very large inconsistencies, and we need to figure out exactly what's happening. And this is especially the case for text messaging. And we need to investigate how this would impact substantive results. One limitation for this approach is that we don't look at systematic error in the sense of the way the average, if the average of the amount of time they spent is different. So we don't look at the impact on the averages. And we kind of do that a little bit with study 2, looking at just Facebook use. So in the second study, we are interested to specifically look at how much people use Facebook. Again, we're comparing survey and digital trace data, and then we're using the donated data as a kind of validation. So to see if which one is closer to reality. And again, the data we use is the same. So now we're comparing, like I said, the survey data with the digital trace data, both from phone and PC. And we use the donated data for the sum sample that gave us the data as a validation to see which one is closer to the truth. We do some kind of fancy modeling. Again, I'm happy to talk about it. We do like a hidden Markov model where we do this model, and we basically treat both the survey and the digital trace data as imperfect. And I can give you an idea of what we found. So we basically found 3 classes of people, or you can think of it as a typology of people. And we didn't give them names. You see here on the top, class 1, class 2, class 3. The size just says what proportion of the sample is in each one. So in class 3, we have 29%. In class 1, we have 38%. And the way to read them is by column, so like a conditional probability. So let's start with class 3. So if I'm in class 3, I have a relatively high probability to say that I don't use Facebook a lot when I answer the survey. And also I have a relatively high probability to say the same thing using the tracking data. So for this class, it's people that don't use Facebook a lot, and it's consistent. Both the survey and the digital trace data say the same thing. For class 2, again, it's consistent, but these are heavy users of Facebook. So both in the survey and in the digital trace data, it would appear that these are people that use a lot. And then we have class 1, which is the strangest one, because in the survey data, it appears they use Facebook a lot, but in the digital trace data, it appears they don't use Facebook. And this is the class that we're not sure what's going on. So the Facebook data, the digital trace data and the survey data for this group of people, around 40% of the sample, they don't agree. So we did more analysis. I'm not showing it here, but from the analysis we did, it would appear that actually the survey data is closer to reality than the digital trace data. And like here we used the donated data as a kind of gold standards. And the reason we did that is that for the donated data, in principle, that captures use from any platform. So if you use your PC or any type of device, Facebook should know that you logged in and you're using Facebook. It is for a subsample, so we need to take that into account, but that seems to be the case. And the other thing that we saw is that the people that are inconsistent, they are less likely to have both data from their mobile and their PC. So it would appear that they might have tracker on one device, but not on all the devices they use. So the digital trace data said, oh, they don't use Facebook a lot. And the reason is that it's just they don't have the tracker on all the devices they use. At least that's kind of our conclusion so far. And we did a little experiment where we said, okay, what if we look at the data only for people that are consistent? So you remember this was the comparison between the digital trace data and the survey. And we said, okay, there are some significant differences. And we said, what if we look just at class 2 and 3 where people are consistent? And we found that for some questions, for example, let's look here at trust in media. We see there's difference between tracking and survey, but if we just look at the people that are consistent, those in class 2 and 3, the digital trace data is getting a little closer to the survey data. And we see, for example, for position left-right, it's getting significantly closer, also for political interest. It's not for all the questions, but for quite a few, also for attitudes towards climate. When we look at only those cases that are consistent, in the survey and the digital trace data, the conclusions seem to be more similar. It's worth thinking that, okay, there's still differences between these data sources. So clearly that does not explain all of the differences we observe. So we need to look more to understand why surveys and digital trade data don't agree and figure out, okay, how we can correct for that or how we can combine them. So another kind of conclusion from this study and overall is that, digital trade data has significant advantages. It collects data very precisely, but it's far from perfect. Yeah, so they're not perfectly reliable. They have method variance, and also it seems that there's a subgroup of people that if they don't have the tracker installed on all of their devices, we might be underestimating the amount of usage we observe with digital trade data. And the thing that we are interested in is also considering how we can combine these different data sources. So if we know, okay, both the survey and the digital trade data is imperfect, are there ways in which we can combine them? Can we get closer to the truth in a way? And the methods that I discussed today, the multi-trade method, the hidden Markov model, both of those are a way in which we can accept or estimate the measurement error, correct for it, and then combine the data from multiple data sources. So we think this is kind of an interesting avenue for the future. And that's my talk. I think I was a little longer than the 30 minutes, but hopefully, yeah, it's enough to get us started to have a conversation about this. Thank you.
Great, thanks so much for sharing this really interesting research. I'm sure we're all happy with results that show there might be, value in polling and surveys still. So appreciate that. Yeah. So I want to get right into the Q&A and the discussion. If you have any questions, feel free to put them in the chat, as I said, or use the raise hand feature and we can get to your question. Hannah Ridge said, what's it like to IRB this kind of tool?
Sorry, what's IRB? So I'm being very thick, but
the institutional review board, like the ethics.
Oh, okay. Okay. Yeah, it's kind of interesting. So for example, the digital trade data, it's in a sense similar to survey data because the company collected all the data, they keep everything. So when we ask the data, it's anonymized. So it's in a sense not different from a survey, like a normal survey on our side, because they do everything. I imagine it would be different if it would be like you and we collect all the data and we need to think, okay, how to maintain privacy and so on. And then for the data donation, again, these online platforms that we're using are very useful because there's basically just an ID that users rename their file with an unique ID and they upload it, but there's no private information. And like I said, these platforms are being developed to actually, sometimes they don't even give you the data, they give you some summary statistics. So you could say, okay, I want, let's say, the average Facebook use in a day. So you as a researcher never see the data, you just see some summary statistics that are given to you for for whatever topic you want. Probably Florian and Ruben would be better to ask because they did the data collection in Germany. But I would say it's not that complicated. It probably is different if you do all the data collection. Then probably I think you need to be a little more careful. And I do think these platforms are a good way forward, where it really makes your life much easier to do the data donation. And also, I would know that it might differ a lot by country. So, Germany might be different from US and UK in the way they go about doing this.
Great. We have a question from Olesia Kacheva. Sorry.
Okay, you almost got it right. I'm joining from Brussels, and that's why first of all, a very great project and congratulations. And some parts gave me goosebumps because with GDPR, what you can see, what users doing in terms of their applications, like, okay, ERB is important. But my question is more like measuring, right? You find a very interesting puzzle. So in some cases, the divergence between people saying I use it a lot when in fact the application shows. And from this point, I'm wondering, suppose I have my Facebook installed on my cell phone and it's constantly logged on. Is it considered to be I'm constantly using it? Or am I using it only when I decide to check what were the updates, but I'm not log out of this? So where is this potential discrepancy comes in? That's one question. The second question is, surveys, we like surveys because people don't have to use Facebook. They can say, I don't use Facebook, especially younger generations, they use TikTok or something else. Here, you force people, so you clearly like have censored kind of sample because these are only users, and given that they're users, then how long they used it, okay? So this is where potential issue might arise. And then don't knows, okay? So that's another third question for ethical considerations, right? We like surveys, and this is very extensive reviews that respondents should be allowed to skip questions at any time. Now, here you go. You have this app that sucks everything pretty much. How do you go about this part? I will stop here, but it's an exciting project. Congratulations.
Thank you. I'll start from the back because that's what I remember. I might ask you to repeat the first question. So, one is, so from what I know, the digital trade data captures the things you're looking at. So it doesn't, you could have 10 apps open, logged in, but it matters if you're looking at the thing and it's active. So you're actually looking at it. But I agree, it could be open and you could talk to your friend and I'll look at it. So it is, you know, kind of an approximation. Sorry, I'm trying to remember the other, with the nose, well, you get a consent. So when you install the digital tracker, you consent to install it, and then you can stop it whenever you want or uninstall it. So, you know, it's a way in which you can take your consent away from this. So there's no way in which you could force the user to keep it forever or not be able to. I mean, you know, the people that Google or Apple, you can't do that because they collect data all the time on you. But this is just an app, so people could uninstall it whenever they decide not to give consent. With the data donation, again, there's a consent part. So we invite them, they consent, and then they actually have to do this. So Florian is leading on a paper where we look at all the stages, because the first stage is, would you be willing to do this? Then do you actually do it? Then do we actually link, are we able to link the data with the survey? And you lose people at each point in time. And so one of the papers we're looking at is to understand the non-response or the selection at each point. So because for consent, you might lose people that have, privacy issues, but for actually uploading the data might be people that are less technical. They don't know how to, do all the stuff they have to do on their PC. So you can have different selection probabilities depending on the way you go about it. And I think there was another question that I forgot. Sorry, could you repeat it?
I mean, you kind of touched upon this, because with the trace apps, then you have people who use those apps, but there is non-user part we're not capturing, right?
Yeah.
So it's like, first they have to be able, they want to have Facebook account or some other account, and then they want to let you see how frequently used. In surveys, you hit pretty much, hopefully, everybody with different levels of engagement or involvement with those apps. But anyway, it's a great project, fascinating though.
Thank you. If you want to do something similar in Belgium, let us know. We're looking forward to to do something like this. I mean, there was something else I wanted to do. Yeah, so in the first study, we were looking at how people use their phone in general. So it didn't depend on the platform. The second study was just looking at Facebook. And because of GDPR, actually, whenever there's a platform that you can collect your own data, in principle, you could ask people to give their data. And I don't know, I'm actually very excited because it's like this effect of GDPR where people, well, they own their data. And we can ask them as researcher if they're willing to share it with us and try to figure out, is there a way in which they would be okay to do that? And I think it has great potential, and it gives power to the user. it's a lot of work for the user currently, but they decide what data to share with whom. And I actually think it's a good effect of GDPR. And also it's exciting because you see the data that the platforms have about you. So you can go and download what Facebook thinks about you, and it gives you an idea. Yeah.
That's exactly what I want to do after the talk. I want to see.
Yeah, surprising results to see what interests Facebook thinks you have. But yeah, you should work with TikTok or Google or YouTube or other platforms as well. Yeah. Thank you for that.
I had a question about, so it was all the same people in the study that did the survey and did the
Yeah.
And
yeah,
what were the consent rates for each? Like, did everybody that was in the survey participate in the digital trace, or
sorry. Yeah, we did have, so we don't know everything because part of it came from the platform. So we had some requirements for the platform. We said, okay, we need a sample of people that have the digital trace data and are willing to do the survey. And we asked for a minimum sample size for the 3 waves. But again, some people dropped out. They added new people at some of the waves. People were, I think we had around 2,000 people that consistently were present in all 3 waves. So that's on the survey side, which is a pretty good result because in a probability panel, attrition appears. So we would have expected actually to lose more people. So attrition was okay. We don't really know with the digital trace data because we got people that have digital trace data. So we don't know, let's say the platform has 100,000 users and 10,000 give the digital trace data. This is the information we don't have. We don't know how selective within their overall panel this group is. We do have these quotas and some weights for the overall population. The only part where we know the entire trajectory of non-response would be with the data donation. And this is where, like I said, this paper we're working on, where we could see all the stages. Okay, do they participate in this 4th wave? Are they willing to donate the data? Do they actually do it? Can we link the data? And there we can actually really go and dig in and see what are the non-response patterns. If you design your own study, let's say LAPOP decides, oh, let's do this for a subgroup, then you can, depending on your design, you can figure out the entire selection process and see, how many people and who are the people that you lose. So let's say you have the main survey and then you ask people, donate your data. Then you see, okay, I have this non-response for the survey. I have this non-response for the data donation. So you see the entire process. Because another organization gave us the data, we are missing part of that selection. So yeah, there are advantages and disadvantages. It was easier for them to do all of this, but there are parts that we don't know because of that. There's a question about which survey measures best. So let me, which survey measure is best? So if I go back, I think out of the survey, the duration seemed to have been the best measure that we used. So and it's kind of interesting because when we looked at the scales, a lot of the scales have been used for a long time. So you could ask people, how often you use, I don't know, the internet once a month. Maybe, 20 years ago, that was a valid response question. That would be like, in an hour, how many, or how much time you're not connected to the internet. So I think there is scope to improve the scales, the response scales in how we collect information about online behavior, because things have changed a lot. And I think this is a trade-off. If we want to do long-term comparisons, we want to have kind of the same response scales, but it's kind of, if we look at the distributions, most people are doing this very often. So we actually need some extra categories to understand, differences in how often people are doing. I think the duration is a good one, but again, there's research, like in survey methodology, there's research that these types of questions also have issues. So it's a little hard for people. That measure seems very precise, but people don't really think in that way. So they kind of approximate and say, okay, I think I do it around 3 hours, but it would appear, I think it appears more precise than actually it is, because people tend to just approximate.
One thing I was wondering is, how do you measure the political variables with the digital trace?
Oh yeah, so that's a really good question. So all of those dependent variables, they came from the survey. So in the survey, because this was like a politics survey, we had all of these questions. So, and that could be a limitation in the sense that all of these are not questions about online behavior, but they do come from the survey. So maybe you'd expect them to be more similar with the survey. I'm not sure. There are ways in which you could do it, but it's a little complicated, and I'm not sure if there's a direct way. So we could look at the websites they go to. We could look what apps they have on their phones and stuff like that. So we could make some measures and see, okay, how are they positioned? But yeah, you can imagine that's quite a complex task, and I'm not sure if there's a way in which we would all agree how we can use, I don't know, web page visits to decide, I don't know, your attitudes towards the left or your attitudes towards climate. But I think that's an area where political scientists and people from communication studies are looking. How can we use this digital trade data to understand the people's actual values? So we could ask them, okay, do you support the left or right, or do you support more spending for the government? But could we use this digital trade data to measure those things? I don't think there's a way that is standardized to do that, but I think that's kind of an interesting area that people are looking at.
Maybe with the Google searches, like what kind of words they're using.
Yeah, some of our colleagues did look at that, like even stuff about health or things about the environment. Can we, I don't know, could we infer the people's values based on their behavior? And yeah, I think that's an interesting area of research.
So I guess I'm not understanding what that graph was showing then with the red and blue regression coefficients.
So it was a question from the survey. Let's say their attitudes towards climate change. Yeah, so do they think climate change happens or something like that? And then we had a regression with different controls like education, age, and so on. And then in one model, we had how much Facebook they used based off the measure from the survey. So let's say in the survey, they say, oh, I use daily Facebook. So that's one model. And in the other model, we have exactly the same thing, dependent variable control, but the Facebook use is from the digital trace data. So based on the digital trace data, how much they use Facebook. So basically that graph says, okay, if they use Facebook, maybe I should share it. If they use Facebook, let's see. Yeah, so let's look at an example here. Political position left, right. So if you use digital trace data, it would appear that Facebook use does not impact your position, your left-right position. Yeah, so there's no relationship between these two. But if you use Facebook use from the survey, it would appear there's a relationship. And I don't remember exactly how the dependent variable was coded, but basically the more Facebook use, then you're more to the left or right. Yeah. Okay. I hope that kind of makes sense. So the dependent variable does come from the survey. So there are different questions from the survey. And basically we had two different models with controls and Facebook use either from one source or another, and trying to figure out if there are differences. And the reason why this is important, if we think, well, I don't know, people change their behavior because of fake news or because of, I don't know, echo chambers. So you can have research questions where you say, well, I think Facebook use has an impact on how much they trust politics. So I think it's a reasonable substantive research question. And the question would be, well, do you have the same conclusion if you would get the Facebook use from the digital trace data or from the survey? And for some you would, for others you wouldn't. And then kind of that's a motivation to dig deeper and try to understand why they're not consistent.
Okay, that makes more sense. Thanks.
Yeah, thank you for that. Yeah, that's a good question.
I can try if nobody has any more questions. I should not be dominating the discussion. I'll pause. I just want to throw a hypothesis at you on the discrepancy. Did you look at the quality of the overall answers to the survey in general? What I mean, how many questions did they skip? Like number of don't knows, number of refusals, duration of the survey, how long it took them to complete the survey. I don't know what you have. And depending what other follow-up questions you usually ask the person or who did the survey, depending what kind of survey. Because my hypothesis would be the more don't knows, general questions in the survey, the higher the discrepancy between the trace and the survey level results. The gap is wider.
Yeah, I mean, we did think that, you know, the data quality from the survey might have issues, and maybe that's causing it. One of the nice things with the two methods that we use is that we don't assume they're perfect, either the digital trace data or the survey. So we kind of assume that, okay, they're both imperfect and we can estimate that. We could try, so for the hidden Markov chain, we had some controls, for example, how many devices they have, their education, and some other controls. I don't remember if we included things around missing data or timestamps from the survey, but that's something we can look into to see. Yeah, another possible explanation would be the quality of the surveys, basically, and try to get some indicators from there. Yeah, that's a really good point. Thank you.
Okay, well, I guess we can wrap up there. Are you able to share the paper, or is it still?
I can. So one paper is under review, and the other one we're writing. And okay. I can share the slides if you want. And once the paper hopefully will be out in 5 years or how long it takes, I can give you the link. Yeah. So there's a special issue coming in computer. How is it called? Social science computer review around kind of digital trace data. So we submitted there the MTMM paper. So in a year, maybe that special issue will be out, and if we're lucky, our paper will be there as well. But yeah, so far I can share the slides, and if anyone is interested, I can share the draft paper, but maybe not publicly at this point.
Yeah, for sure. Well, we look forward to reading it, and thanks so much for taking the time to share the research with us. I think it was interesting and useful for all of us. So please join me in thanking Dr. Cernat for coming this week. And this is our... Go ahead.
Yeah, thank you so much. And let me know when LAPOP will implement this kind of data collection.
Yeah, for sure. All right. Well, that's our last talk for the semester. So stay on the email list, and we'll come out with a new set of speakers and rejoin in the fall. So thanks, everybody.
Thank you so much.
Bye.
Bye.